Topic 13-5, quadratic applications. In the previous topics, you have been solving quadratic equations. I'm going to tell you that quadratics will either look like this or look like this. So in application problems, I'm going to be throwing something up. And when I throw something up, it's going to have a max height. And this is going to be the ground. And this is also going to be the ground. Okay. Most of the applications are like this, not like this. Famous ones are arrows and area for quadratics. So if we're doing area, you'll see that in the next example. But arrows, if you shoot an arrow, it will go up and then it will come down. So first one right off the bat is an archer shoots an arrow into the air. The equation that describes the path of the arrow is that, where h is the height and t is the time. So you're going to shoot it up. It's going to go from here to here. The independent variable is time. The dependent variable is height. So the height depends on the time. And so what you're going to do is, how high is the arrow after 2 seconds? Well, if I have h equals 17t minus 5t squared, and I have 2 seconds, t equals 2, I'm going to substitute my t in for my equation. So, and I'm wanting how high, so I'm wanting h. That's what I don't know. Equals 17 times 2 minus 5 times 2 squared. 34 minus 5 times 4, 34 minus 20, which is 14 meters. And it does say height in meters. When will the arrow be 10 meters high? So when, you're looking for time, and h is 10. So 10 equals 17t minus 5t squared. Just like everything else, you're going to have to set it equal to 0. So I'm going to swing everything this way. So 5t squared minus 17t plus 10 equals 0. Factors of 50 that add up to 17. I don't think of anyone off the top of my head, so I'm going to do the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that turns out to be 17 plus or minus the square root of 89 over 10, which that becomes 17 plus the square root of 89 over 10, and, 17 plus the square root of 89 over 10, and 17 minus the square root of 89 over 10. Where this is 2.6 seconds and this is 0.8 seconds. So if you have a graph at 2.6 seconds, so this is the 0 time, as time goes, 2.6, this is the height, so this is 10, and this is 10. Actually, that would be 0.8, and that would be 2.6. But notice it's going to hit 10 meters on the way up and 10 meters on the way down. When will it be 20 meters high? So I'm going to do 20 equals 17t minus 5t squared. And then I'm going to swing it again, because in order to solve quadratics, you have to set them equal to 0. 5t squared minus 17t plus 20. I'm going to do the quadratic equation again. So I'm going to do the opposite of b plus or minus the square root of b squared minus 4ac and all over 2a, and that becomes 17 plus or minus the square root of 189 minus 400 all over 2 times 5. That's going to be a negative square root, and when you put a negative square root into the calculator, if you do that at your juncture in math, you are it will say error, so it's the square root of 211, 17 plus or minus square root of 2 over 5. When you put a negative square root into the calculator, it will say error, because for right now, this doesn't exist. This actually, the negative square roots do not exist until pre-calc. Probably late algebra 2 pre-calculus. So error, this would indicate it never reaches 20. So we know it reaches 10, but the height is less than 20 because 20 causes this to be a negative square root. When will it come back to the ground? So ground means height is 0. When is t? So 0 equals 17t minus 5t squared. Then I factor out a t, and I have 17 minus 5t equals 0. So in order for this thing to be 0, this has to be 0 or this has to be 0. So t equals 0 or 17 minus 5t equals 0. And so I have the time at 0, t equals 0. And then this would be negative 5t equals negative 17. T equals 17 over 5. So it hits the ground at time equals 0. That's the start. That's this right here. That's the start. And then it goes up and comes down, and it lands at 17.5 seconds later. And that is actually 3.4 seconds. So it lands at 3.4 seconds and on the ground. And when will it come back to the ground? And that's what it is. This 0 is when it took off. This 0 is when it lands. And that is the first part of topic 13-5, quadratic applications. Make sure you understand that most of the application problems are throwing something going up, something coming down, looking like this, where there's a max. Here's the 0 for height, and your x-axis is time.